Hi everyone, Jason from Makera here with another project tutorial. And in this one, we're looking at how to create a slide card style fidget toy using the Carvera and Makera CAM. Using the Fidget Toy Tool Kit available in our store, you can manufacture a wide range of fidget toys using your desktop CNC and the materials and bits included in this tool kit. Through this tutorial, we're looking at how to make a slide card style fidget toy, which will involve some intricate toolpath design for a multi-sided metal project. You can choose to design your own CAD files for this project, or you can download the 2D CAD files that I'm using in this tutorial from the knowledge sharing page on our wiki site. You can, of course, download the CAM files from the wiki page too, but through this tutorial, we're going to look at how to create our toolpath step by step to make this project using Makera CAM. So let's get started. All right, after launching Makera CAM, the first thing we want to do is set up our stock parameters for this project. So we can edit our stock, and you can choose whichever material you're going to be working with. I am going to use brass, and I'm going to use a piece of brass stock that's 100 millimeters in length, 100 in width, and 5 millimeters in height to create this fidget spinner from the fidget bundle pack that you can find in our store, as mentioned earlier. After setting the stock parameters, we then want to import our files. So there's a number of files that we're going to need to first create the top of this fidget card, starting with the outlines file, followed by the logo files, which there are 2, and then the stripes file. We won't need the bottom file for this side, but we'll get into that when we actually flip our stock over and manufacture the bottom. Now you'll see that as this file was created, all the design files aligned perfectly because they were all designed together and then exported in a CAD program. But you could, of course, use center to center to align your design files if needed, as discussed in our other tutorial videos. Now, the first thing we're going to do is create our stripes. And the stripes are going to be manufactured using this stripes file. You can select the entire design by hitting Select Graphics using the Layers panel here. And we're also going to create an outline stripe as well. So I'm going to hold Shift on my keyboard and select these 2 inner outline. So that's actually selecting things from 2 different layers, but that's perfectly fine as we want to create our toolpaths using the same parameters for these design features. So with the parts of our design selected, we can then create a vector contour toolpath. And one thing that we're going to do differently for this project is we're actually going to start machining in the negative. So I'm going to start machining above my stock at, let's say, negative 0.1 millimeter. And the reason we want to do that is we want to ensure, and I'll do negative 0.1 just to make it a little bit easier to see and read there. We want to ensure that our stock and our project is cut perfectly square, right? In another video, we talk about how to use the Carvera's auto leveling feature. And what that will do is automatically adjust the Z height during machining to give you an even cut. But let's say that your stock is slightly uneven, not perfectly square, which is very common for extruded stock and things like that. Then the cuts won't be perfectly square. They'll actually be square in relation to however offset or whatever the deviation is on the surface of your stock. By starting your machining depth above the stock, the Carvera will begin the toolpath above the stock and then gradually decrease into the stock, giving you a perfectly square cut based on the machine's square axis gantry. This gives you a nice square cut, which is really important when you want to do parts that fit well together, like our fidget slide card. So we're going to start at a depth of negative 0.1 mil. So that's going to start machining above the stock, as just mentioned. And we're going to do a depth of cut of 0.4 mil. Now, you don't typically need to adjust your safe positions unless you have some type of jig or fixture that you're working around. And for the tool, we're going to select our 1.5 by 6 millimeter end mill in our metal bit. So 1.5 by 6, our parameters for brass should automatically be selected as so. And in this case, we are not going to adjust any of these parameters. These are perfectly fine, but you might want to consider adjusting the tool number depending on where you have this tool loaded. And this tool is also part of our fidget bundle as well. Now, for our strategy, we're actually going to cut this on vector. So that way the tool is going to follow these lines and cut them right where they are in our design as we go. We can enable a climb method, And we can also enable ramping as well, which will give us a nice gradual start to the machining and will allow us to reduce the wear on our bits and get a cleaner cut. So for ramping, a good distance is usually 10 millimeters for something like this. And we can do a fixed angle of 2 degrees and a start height of 0.5 millimeters. No tabs are needed, of course, because this isn't a contour cut that's going to go all the way through. So we can go ahead and calculate our toolpath, and we should be able to see our cut strategy, a nice little design cut there into our stock. Let's close this, and we can then move on to our next toolpath. And this one is going to be a pocket toolpath for our logo graphics. So we're going to select all the graphics on our logo layer. And in this case, one of the best ways to do this might actually be hide all your layers and your toolpaths except for what you need, and then go ahead and drag a box and select all the graphics across these 2 layers, like so. Then we can go ahead and create a vector pocket toolpath. So we can machine out this design using a pocket strategy. Again, we're going to start above the stock, so negative 0.1 mil, and the end depth for this will be 0.4 mil again. We're also going to enable a last pass depth, and what that will do is essentially enable a finishing pass at whatever our step down is set for our bits as we go. Speaking of bits, we can go ahead and select a different tool. In this case, it's going to be an engraving bit for metal, such as the 0.2 millimeter by 30 degree V-bit would be perfect for designing or machining a nice detailed design like this. Again, our brass parameters will be set automatically based on our stock. You'll see that the previous tool that we were using is still here. If you were using a previous tool, that's if you did want to do a multiple clearing path or like a rest machining type path. In this case, we don't need to do that. So I'm going to delete this other tool so that way all I have is my 0.2 mil by 30 degree engraving bit. The default parameters should be fine, but again, you might want to consider adjusting your tool number based on where you have this tool loaded in your tool changer if you're using the Carvera. For our strategy, offset and the default parameters of climbing should be fine. And again, we're going to enable ramping. This time we'll ramp for a slightly longer distance as we're working with a smaller bit here, and we don't want to break the tip, just to give us a nice, more gradual entry. So we'll ramp distance for 20 millimeters, 2 degrees is still fine, and a start height of 0.5 millimeters is still fine, and a good general strategy for this. We can go ahead and calculate. And we can see our pocket path generated within these logo designs. So we can close this now. And if you want, you can actually enable your contour path as well. So you can see how the 2 toolpaths we've created thus far will align. And I'm going to go ahead and hide our logo design files because we won't be needing them. And then we can enable our outlines design file because the next thing that we're going to do is follow along with this outline and begin to cut the outer perimeter of our fidget toy. We're not going to cut all the way through on the top because we are going to flip our stock over, but we're going to begin to cut in so that way we can create a nice chamfered edge for the top. And then through some alignments, we'll be able to make sure that the top cuts align with the bottom cuts. So let's select our 2 outlines and then create a new vector contour toolpath. Again, we're going to start from a depth of negative 0.1 above the stock. This time our end depth can be 1.5 millimeters. So then not all the way through, but deep enough that we can start to cut the outer edge. For our tool, we can switch to a larger tool, such as a 3.175 by 12 millimeter flat end mill with brass set as our machining parameters. Our default parameters should be fine for brass as we work here, but you do need to change your tool number if you have a tool number set that we've already used. So for example, I'm using tool 4 for my smaller flat end mill. So I'm going to switch this one to be tool 5 as you go. And that's important to do whether you're using the Carvera with the automatic changer or even the Carvera Air, so that way a tool change will be prompted to a different bit. For our strategy, we're going to run along the outside of the contour. No offset and climb is fine. And again, we will have ramping enabled, and we should have our default parameters that we set earlier on with a distance of 10, an angle of 2, and a start height of 0.5. So let's go ahead and calculate this, and we'll see that we have this outer cut set. And if we rotate, we'll see that we don't go all the way through, but we cut deep enough that we can start to machine a chamfered edge as well. Now, the last thing that we have to create for the top of our design in terms of the fidget toy is a chamfer to give us a nice smooth edge to work with. So let's go ahead and select those same outlines again. And let's go ahead and create a contour toolpath again. And for this one, the start depth is actually going to be within our stock because we've already begun to manufacture this path. So we're going to set a start depth of 0.2 and an end depth of 0.6. For our tool, we can go ahead and select our chamfering bit, which in this case will be a 0.1 millimeter by 90 degree chamfer from our examples pack with brass set as our default parameter. The default feeds and speeds should be fine, but check your tool number to make sure you're in a different slot. And the key about a chamfer is you typically want to run along the outside of your toolpath like a contour cut, but you also need to offset the chamfer bit. The edge of the bit will be over the line, and that's what creates our chamfer cut. And this offset is what can set the size or the depth of your chamfer. So for example, we're going to offset negative 0.8 millimeters, which should give us a nice even and small chamfered edge for the size chamfer, or 3.175 millimeter diameter chamfer bit that we're working with here. Climb is fine, as with before. And for the chamfer, we actually don't need to enable ramping. Once we calculate, we can see our chamfering bit running along the inside of our line here. All right, now the last thing that we need to do for our top side of this project is to give us some alignment pins, so that way when we flip the stock over, we can be confident that the stock is aligned with the top design and the bottom design, which is super important anytime you do a multi-sided project like this. So we're going to use the Makera CAM create feature to create some holes that we'll put alignment pins in later. The diameter of these holes can be 2 millimeters, and the position of the first hole is not important. So we can go ahead and just draw it somewhere in this lower corner here, like so. And you'll see that this was drawn on our first layer, which was the active layer. Now, we need a second hole on the other side of the stock. And there's a couple ways we could do this. We could actually transform this hole using the transform window and set the position to be specific off the corner, and then kind of do some math to make sure it's in the exact same position on the other side. But there's a much easier way to do this in Makera CAM, and that's by using the mirror tool. So what we're going to do is we're going to mirror this hole, but rather than mirroring it off of its own center, like the center of the hole, we're going to mirror it off of the stock center. So that way, this is going to find the center of our stock, and I'm going to click Create a Copy, and when I hit Mirror, a second hole is going to come to the other side, the right-hand side of the stock, and it's in exactly the same position based on the size of my stock. So that means as long as I machine this project on a piece of stock that is 100 millimeters in width here, when I flip this stock over, my designs will be perfectly centered based on these alignment holes. Now, with our holes drawn, we can select both holes and create a vector drilling toolpath. For this, we can set our start to be 0 millimeters. That's perfectly fine. Our end depth is going to be 10 millimeters to give plenty of space for the pins to slide through. And this, of course, will not only go through our 5 millimeter stock, but it will also drill 5 millimeters into your spoil board or your waste board. So make sure that you have a piece of waste board to protect your bed accordingly. We can go ahead and select a 2 millimeter drill with our brass properties selected here. And the default parameters are probably fine, but go ahead and check your tool number to make sure that you have this in the correct location. And we also want to do a retract path. So this is like a peck drilling function. And we can do this from a relative retract distance of, let's say, 2 millimeters, which just means that each drill pass will then back up or retract by 2 millimeters to allow for chip evacuation to make sure that we don't dull or break our bits. We can hit calculate, and then we see our tip or drill path drawn there. So this concludes the top of our project. So this will manufacture the design and the chamfer and everything like that on the top of our fidget project. And then what we need to do is flip the project over to manufacture the bottom. And you could do this in 2 separate CAM files, but we're going to do it in just one. So the first thing we have to do is make a new work coordinate system for the bottom of our stock. So to do this, we can press this plus button here to create a new coordinate system, which I'm going to call bottom. And then we need to select the origin point for the bottom coordinate system. And you can see that the default origin point is, of course, the top left corner here. So we want to select what the top left corner will be after we flip our stock. And if I rotate my stock around in a horizontal direction like this, which is how it's going to be flipped, I can see that this corner will actually end up being the bottom's top left. So we want that to be our origin point for our new WCS. And when we press OK, we can see that we've created this bottom WCS, and we can sort of see a shadow of our designs from the top. And I can toggle back and forth between the WCS accordingly. So now we need to import the design files for the bottom of our fidget toy. And for this, we're going to need the same outline file that we used earlier. And we're also going to need the design file called bottoms. And again, because these design files were made together, they should align with the tops just fine. But if needed, you could use the center to center feature to align, as discussed earlier on. And now we can move into actually preparing the toolpaths for the bottom. So the first toolpath that we're going to create is actually just for this little post here that we can see on the left side. Now this post is going to be what slides in this channel to lock the two pieces of our fidget toy together. And all we need to do is remove a little bit of height off of this post so that way it fits within this groove. So we don't want it to be the same thickness of the stock, so we just have to machine a little bit of material off. So we've selected this hole and we're going to create a vector contour toolpath. Our start depth is again going to be negative 0.1. So we start machining above, and we can do an end depth of just 0.3. So that's just going to remove 0.3 millimeters off the height of this post. We can choose our single flute bit that's 3.175 by 12 mil. Again, our parameters will be preset, and we shouldn't have to adjust anything here apart from our tool number. Earlier on the top part of this project, I set this to be tool 5, which I'm going to do again, so that way I don't have to move the bits around in my tool changer when I flip my stock around. We can set this to be on vector, just so it will run along the size of this post. And just like before, we can set ramping at a distance of 10, an angle of 2, and a start height of 0.5. After calculating, you can see that it's just going to manufacture this little post here, which again will just remove some height off of our material. Next, we want to go ahead and manufacture this pocket on the left side of our stock. So to do this, we're going to select everything on this side, like so. I don't want to grab the outline design part here, just the inner part of this pocket. So I'm just going to hold Shift and deselect that one aspect of the design. And then we can go ahead and create a pocket toolpath. We're going to start from negative 0.1, but we're going to end at 1.8 millimeters as we go. We're also going to enable a last pass depth, which again, as we discussed earlier, is sort of like a finishing pass, to 0.02. So that's going to give us a really nice fine and smooth cut here, which is important because this part's going to have to fit in with this part that we machine later. The tool that we're going to select is going to be our 3.175 by 12 millimeter bit, which we again want to set to tool 5. And that's going to start our clearing path. We don't need to use our engraving bit if you have this already there. So I'm going to delete that. So all I have is my 3.175 by 12. And that's going to start this. But this bit is too big to fit into the fine details, into the corners for this. So we're going to add a second tool. We'll grab our 1.5 by 6 millimeter tool, which is set to tool 4. And this will be selected after most of the material has been cleared out by the larger 3.175 bit. And then the smaller 1.5 millimeter bit will just be used to clear out all the sharp corners and things and actually do that finishing pass that we set earlier. So the default parameters for both these bits should be fine. Just make sure that you have the correct tool number selected. Our path strategy is going to be an offset with outside in and climb. The default is perfectly fine. And we do want to enable ramping. And because we're using a smaller bit, we can do a larger ramping distance. So 20 millimeters at 2 degrees for a height of 0.5. So this will go ahead and clear out our path here. And actually, I made a mistake with this. And what I did was I selected my magnet holes. I don't actually want to do that. By doing that, that means that the magnet holes are not going to be cleared. That was a mistake. So I want to select just the outline of this as well as my post. So let me just hide this here. So I'm going to select the outline and my post, and then let me recalculate. And then what you can see is that this entire path was cleared, magnets included, everything was cleared apart from the post. All right, the next thing we can do is we can start to clear out the material on the right side of our fidget toy. And the first thing we're going to do is clear out this large outer perimeter piece here. So I'm selecting this sort of U piece. What that's going to do is machine material away from the outside of this piece of the fidget card. And that's going to allow us to slide the two fidget cards together as we've machined a pocket on this side and an outer path on this side. So what's left on the right side will fit in what's been removed on the left side here. So after selecting this, we can go ahead and create our another vector pocket path. For this, we're going to do a start depth of negative 0.1 again. Our end depth isn't going to be quite as much. We'll do 1.5. That way there's a little bit of a gap between what we've removed on both sides to allow it to allow the two pieces to fit through. We are going to enable our last pass depth of 0.02 for a nice finishing pass. And for this, in this case, we only need to use the smaller bit. So I'm going to remove this 3.175 by 12. So that way all I have is my 1.5 by 6 because we need to fit within this slightly smaller area here, and the larger bit won't do that quite so well. However, we can adjust our parameters a little bit. So we can reduce our step over a bit. So I'm going to change this to 0.4, and that is going to make this take a little bit longer because my step over isn't quite as big, but it's also going to give us a more gentle cut and reduce the wear on our bit here. The other parameters should all be fine. We do want to change our path strategy to inside out, so that way the bit will start on the inside and work its way out to give us nice, clean, sharp corners, and again, reduce the overall wear on our bits. And again, you want to make sure that you have your ramping set, just like we did before. Next, we're going to do another pocket, and this one's going to be this inner groove cut on the right-hand side. So we can select this inner groove and then create another vector pocket. We're doing this with very similar settings to the one that we just did, but the reason that we didn't do these two paths together, this outer U and this inner pocket, is because we need to have different depth. This center groove needs to be deeper than this outer groove because this is where our peg, our little post thing that we cut earlier, is going to fit into. So our start depth is going to be the same. Our end depth is going to be 1.7 millimeters. And again, we can enable the same last pass finishing. We can also enable our 1.5 by 6 bit again. I'm going to readjust the step over to go back to 0.945, which is the default parameter, just to give us a slightly faster machining pass for this inner pocket here. And all the other settings that we used earlier, offset, inside out, and our ramping strategy should still be applicable for this toolpath. All right, so we have our pocket cut out on this side. We have our outer perimeter and inner pocket cut on this side, which should allow these two pieces to fit together. The next thing that we have to do is manufacture our magnets, so all these little magnet holes as we go here. Now, we could choose to manufacture these magnet holes together on a single toolpath, but we can actually save a little bit of time if we do it separately because the magnet holes on the left side have already been surfaced, right? So the magnet holes are already down here on this side below this pocket path that we've already started to machine, while the magnet holes on this side are a little bit higher up because we haven't machined the center of this. So if you did the toolpaths together, they would all start machining from the same height, which means that this left side would be machining with no stock until it actually reached where this pocket was already cut. So because of that, we're actually going to do two toolpaths, one for the left side, one for the right side. They're going to be almost the same settings, just with different starting and end depths based on where the magnets fall. So just to clear this up a little bit, I'm going to hide all the paths that we've already selected. And then I'm going to select the magnets on my left side by holding Shift, and we can create a pocket toolpath. The start depth is going to be within the stock, 1.8 millimeters, because we've already machined down to that depth. And the end depth is going to be 3.9 millimeters into our part. Last pass is going to be enabled, so we get a nice clean finishing pass for this. And we can make sure that we have our 1.5 by 6 millimeter end mill. And the default parameters, default step over, all of that should be fine for this pocket path, as can our offset with inside out be selected and our ramping, just like we did before. So I'm not changing any of these things. You should still have these same settings from the last pocket path that we created. So you can see that we have our magnets, and you can also see that this toolpath starts in the stock. And if we enable this pocket, you'll see that that magnet toolpath starts where that pocket path machined to. Now let's close this and select the magnets on the right side and create another vector pocket toolpath. We can change our start depth and our end depth. In this case, we're starting from the surface, so we're going to actually go above the surface, negative 0.1, like we did before. And the end depth for this is going to go to 2.1 millimeters. So we have enough material machined out for our magnets here. All the other settings should be perfectly applicable and should still be here from the last pocket that we created. So our last pass depth, our tool parameters and number, our strategy, and our ramping. So now we've created the magnet holes on this side. Now, if we show all of our paths, we have nearly everything we need, apart from actually cutting out this part. So we actually need to cut the part to release it from our stock. So let me hide everything here. And for this, we're just going to select the two outermost perimeters, which is of course what we use to start the outline path on the other side of our stock. And we can create a vector contour toolpath. Our start depth is going to be negative 0.1 because we'll be machining material and we want to make sure this is nice and square, as discussed earlier. The end depth is going to be 5 millimeters, so we can cut all the way to the bottom of our stock as we go. And if you want, you can do something like 5.1 millimeters just to make sure that you do manufacture all the way through the bottom. We'll use our larger 3.175 by 12 millimeter tool, which is set to be tool 5. Our default parameters should be fine. For our strategy, we're going to do outside, but with an offset of negative 0.17 millimeters. And what that lets us do is run along the outside, but bring our bit inwards just a little bit. And this helps when you're flipping your material over. So that way, if your alignment isn't perfectly square, you'll machine a little bit of material away from the outer cut that we did on the top, just so that way your design will still line up. You'll remove any excess material just by a small margin here, just in case your alignment isn't perfect when you flip your stock over. We want to enable ramping just like we did before because we're working with a larger bit. We don't need to do such a large distance. 10 millimeters is perfectly fine. And you have the option of enabling tabs and putting tabs in along the outer perimeters here. But for a project like this, we recommend that you use double-sided tape that I'll show you in just a minute to secure your parts, so that way you don't have to cut the tabs away, and especially when you have a design that has edges which are crucial for things to fit together, they'll give you a nice cleaner and higher precision cut than having to cut tabs away manually after the fact. So we can calculate this, and if I enable all of my paths and hide my layers here, we can see our paths for the bottom. We can then flip back to the top, and I'll do the same, and you can see your paths for the top, and you can actually see how they interact with one another because we get the shadow between the two work coordinate systems here. And this looks good. The one thing that we didn't do, and it is good practice, is you could always rename these paths. As you can see, we have a lot of repetitive contour processes. So you might find, especially if you go back into a project and you sort of modify things and you tweak things, never be afraid to go ahead and actually rename these different paths like this, so that way you know what's happening in each toolpath, which just makes organizing your design a little bit more easier to go back and manage. And I'll make sure that I do that and label all these things in the design file that's actually shared with you. So with everything designed here, what we can do is right-click and save all of our toolpaths. So we're going to do this in two files. So I'm going to save all of these toolpaths together. So I'm going to save this as top paths, and I'll save that to my computer. And then I can switch to my bottom, and I'm going to select and save all of these paths as bottom paths. and again, save that to my computer. Now with our G-code files prepared through Makera CAM, it's time to set up our CNCs for manufacturing. We can start by securing the stock to the bed of our CNC and make sure that you have a piece of wasteboard below your stock, as we will be machining all the way through the stock for the alignment holes and to cut the part out later on. And if you're using the Carvera, you also need to make sure that your tool changer is loaded with your bits in the correct order based on our CAM file that we made earlier. For this project, our drill should be in slot 1, the engraving bit should be in slot 2, our 1.5mm end mill should be in slot 4, the 3.175mm end mill should be in slot 5, and the chamfering bit should be in slot 6. We also typically don't use the dust shoe for metal and instead use the air assist module for chip evacuation and cooling, though this isn't always required. Now with our machine set up, we can open up the Carvera controller app to actually configure our G-code files to manufacture this project. So after uploading those 2 G-code files to the Carvera, we can start by loading the top paths file. In our config and run window, there's a couple things we want to do. First off, you can select your work origin. So if you did want to offset this to leave room for clamps and things, you can. But you need to make sure that this offset is equivalent on both sides, because you have to remember that we will be flipping the stock. And in this case, when you're flipping the stock, it is best to set these offsets by manually positioning your material on stock in the CAM software. Scan margin is always a good idea, so we'll enable that so that way you can make sure that there's no clamps or fixtures that will be hit or obstructing our toolpaths. Auto Z-Probe can also be enabled. This will check our general stock height. And as discussed earlier, we don't want to enable auto leveling, as this will give us an even cut, but that will be based on any defects that we might have in our stock thickness. So with all this set, we can go ahead and click Run to start this top job. After pressing Run, the Carvera will start by tracing the perimeter of our job through the scan margin feature. Ensure that no clamps or fixtures are obstructing your work area around the scan margin. The surface will then be probed to determine the height of our stock before selecting the first tool. Our CNC will then move through each toolpath we created earlier in our CAM program. First by machining the top design and logo, before moving on to the outer perimeter and chamfer toolpaths. If you're using the Carvera, tool changes will be automatic between each toolpath, while the Carvera Air will prompt you for a manual tool change. Once the top is finished, we can vacuum away any excess chips, then apply double-sided tape to our parts if you chose not to use tabs in your design like me. But before we flip our stock over, we need to insert the alignment pins included in the toolkit before removing the stock. These alignment pins should slot firmly through the stock and into the piece of wasteboard that we drilled, allowing for an accurate horizontal flip of our stock based on our CAM file. After flipping the stock over, you can remove the alignment pins and press the stock firmly down to adhere the parts to the bed using the tape that we applied, and then of course secure the stock using top and corner clamps just like we did earlier on. After selecting and loading the bottom path file, we can go ahead and go to our config and run, and we're going to do the same settings that we did earlier. So making sure that our work origin offsets are the same or non-existent to make sure that our parts align, enabling scan margin just to check our positioning and our clamps, enabling auto probe just to set our stock thickness, and again, we don't need auto leveling here. The Carvera will again trace the perimeter and probe the surface of our stock before moving through the toolpaths to manufacture the bottom of our designs, starting with the peg and pocket toolpaths before machining the magnet holes and then the outer contour cuts. Once finished, we can vacuum away any chips and dust and then remove the clamps to peel the stock and parts off of the bed of our CNC. Be careful, as there may be some chips and sharp burrs attached to the tape, which can be peeled away from the top of the parts. After checking the fit of our parts, we can sand the edges to remove any burrs and clean up any unfinished surfaces. And then to make this slide card work properly, we need to add the magnets to this project, which are included in our toolkit. You can use super glue to install the magnets, but I recommend you don't glue all the magnets in at first. The number of magnets used will change how your slide card reacts, and you can add as many magnets as you want to increase or decrease the responsiveness of your fidget toy based on your own liking. But the project doesn't need to stop there. We can also add paint to create a multicolored project like this. You can paint the surface of each part, ensuring that the pockets are filled with paint evenly. After the paint dries, sand the surface to remove the paint from the high spots and only leave it in the pockets to give you a nice two-color design with a brushed metal finish using the sanding blocks included in the toolkit. And there you have it. There are, of course, many different ways to create a fidget toy, and many of the processes and techniques shown in this tutorial are universally applicable to these different types of projects. If you choose to make a fidget toy of your own, share it with us through our community channels. And also check out our channels for more how-tos and project guides. And of course, please don't forget to subscribe. And thank you for watching.